So volume of composite figures. There's nothing super magical to this or any different than volume of regular figures, other than the fact that you have to identify that there are multiple figures and multiple things happening. So you have to be able to see the shapes that have been put together to build whatever it is we're solving for. Big call outs when you're finding volume, especially of anything that has a circle in it. So a cone, cylinder, sphere, and all that things. Make sure to read for what they tell you. So if it doesn't notate which to use, more than likely, and it depends on the program and who writes the quiz and all that good fun stuff, you're going to use your actual pi button in your calculator. So the pi button, so it looks like so, in a TI-80, or the pi symbol if you're in Desmos. On the TI-84, it is second up arrow, so right underneath clear. So this guy. So you're going to hit second and that guy, just so you can find it. So identify the different figures that make up the composite figure. In this case, I have, and I like to associate these with things that you know around the house, like a can, a Campbell soup can. So I have a can here, so a cylinder, because it's a prism with a circular base. And then I also have a sphere, but it's not a whole sphere. It's going to be a hemisphere, so half a sphere. So we're going to use our sphere formula, but we're going to cut it in half when we're done. Cylinder, you're going to find the area of that circle, just like before, and then you're going to count how many are in the stack, so then multiply it by your height. So find the volume of each figure you identified separately. So we're going to find the volume of the hemisphere first. So this is our hemisphere. So that formula is 4/3 pi r cubed. Most misconceptions that I see most kids mess up on this guy is you square it just out of habit. And then the 4/3 is a little different than like your cone and your pyramid where it's 1/3. So I make this one in my brain because I know the 4 is strange and raised to the third power is not something I naturally do very quickly. So that's how I learned to memorize this formula. So we need to find our radius. In this case, that 12 is your diameter. So we're going to change that to a 6. So it's going to be 4. We're going to use 3.14 because that's what it said in the instructions. Our radius is going to be 6 because it's half of the diameter. We're going to cube it, and then we're going to divide by 3. Also be careful if you are using a TI-83 or 84, and even in Desmos, that what is on your paper, like in this case, all of that is divided by 3. It goes in correctly. So I sometimes like to break it down individually and check each number just to make sure that I'm speaking calculator correctly. In this case, it is going to give us 2,712.96 divided by 3. I just did the top and then the bottom because most students, the problem, especially in your TI, is making sure all of this is divided by 3, not just the last portion or not just the first portion. And that's going to give me 904.32. This does say round to the nearest tenth. So this would still be 904. Tenth is one spot, 0.3. That is a sphere, though. So super close. And if it was multiple choice, that puppy would be there. But that's not what we need. We need half of that. So hemisphere is half. Hemi is half. So you're going to multiply by 1/2 or divide by 2. And so our hemisphere is 452. And I have 0.16, so 0.2. And if you did the 0.3, and it would be 0.15, which would still round to 0.2. So make sure you're rounding appropriately too. And this is going to be inches cubed. Cylinder. So this is where we're going to find the area of that piece. I love thinking about like bologna because I think bologna is gross personally. So but I know like the Oscar Mayer pack of bologna, when you start peeling them apart, how it sticks together. I don't know why it's a great visual for me. But so I need the area of the one piece of bologna, which is pi r squared. And then we're going to multiply that by the number of bologna in the stack. So times height. Pi r squared times height. So again, pi is going to be 3.14. Our radius, again, is the same as that up at the top, but it's going to be 6, not that 12, because the 12 is your diameter. We're going to square it, and then we're going to multiply the whole thing by 13. So again, you would still see this formula if you go look somewhere else. Big BH. Big B is whatever the area of the base shape is. And base, I know, especially when you start getting into triangular prisms, is a little complicated for some of you to see. So I like to think about if it was a loaf of bread and I was making sandwiches, I want to cut in the direction that's going to make a top and bottom match. And in a cylinder, most students don't have as much trouble, but that means I'm going to slice it this way. Like, I wouldn't want to take this bologna and all of a sudden start slicing it this way, because then as I get in the middle, they're going to be bigger pieces, and it's not a consistent slice. So think about your base is always the shape or the direction that you can get consistent slices. So 6 squared is going to be 36. So 3.14 times 36 times 13. And this guy's going to give us 1,469.52. So we'll just stop at 5. And again, this is inches cubed because it's inches and it's 3-dimensional. That's why it's cubed. Whereas your area, the 3.14 times 6 squared, would be squared because it's just 2-dimensional. Now, we're going to add the two together because that's the kicker, because both of these answers likely would be there if it was a multiple choice. So we're going to do the 452.2 plus 1,469, 0.5, and that's the answer of the composite figure. And that's going to give us 1921.7. And again, that's going to be inches cubed. Hopefully that guy made some sense, guys. Reach out if you have any issues.